Hi there. Thanks for coming to my channel, Software Test Automation for Eternity. In this channel, we're covering various topics on software testing, especially the test automation framework and tools. And also, we're covering software testing fundamentals. And in this particular video is a series of software testing fundamentals. So we're using this interview question to help you understand the software testing fundamentals. So this is a third part three of that sort of series that we're running. And I don't know how long this one will go, but once we cover the majority or the most critical portion of the software testing fundamentals, I think we can move into the automation part and then framework and the tooling. So I mentioned that in the part two, but I believe even for automation engineers or SDAT still need to have a pretty strong software testing fundamentals. That I think that'll definitely help uh, creating a tools or automation framework to support their software testing effort. So we had a part one and part two. This is a part three on software testing interview questions, and I put that as an equivalence partitioning trap. So I'm not going to talk much about the trap portion, but yeah. So this time, this video, we're going to cover equivalence partitioning. Okay. So I don't know if you guys are familiar with the equivalence partitioning in terms of sort of testing strategy. Yeah. So, here's the definition. I'm not gonna go ahead and I'm not gonna read all that, but basically, the equivalent partitioning is to have some range of inputs. I think that they're mostly come up with the inputs, right? So there's some valid input or value that comes within certain range, and then you can actually group them as partitioning, group them in a sort of range, so that is partitioning. So there will be a boundary cases, right? The edge portion, edge value, that it is greater and less than certain value, uh, or just it could be just the string value or whatnot. But basically, there is a group of sort of valid input that kind of does the similar behavior. I think we just group them as and call it the equivalent partitioning. Yeah. So for example, if you here's a simple code to calculate, there's an input, and input will say, okay, if the input is less than 0, throw an exception, and then between 0 and 7, it'll multiply by 2, and then else return multiply by 3. So this is simple sort of you know function there. Maybe that comes it actually associated with some UI in a web page or some input like program that take the input. And the equivalent partitioning means like what are the values that are kind of similar to so how you're gonna group them, right? So it's gonna be the one that is less than 0, and then between 0 and 7, and greater than 7, I guess. And also there's a potential, so there's a big sort of group is so 0, less than 0, 0, between 0 and 7, and 7, and then the greater than 7. I think that's the sort of simple sort of partitioning. And then there's some edge cases like the max value of integer. It depends on whether it's an integer or long, but it has a max value, and then since you're multiplying by 2 and 3, and there might be some group of sort of inputs that you can put. So those are sort of the common equivalence partitioning questions we answer, and you kind of provide those things. So let me kind of go to second question. So the actual example of interview question I have. So you're testing a medical device, and this device specifies that the device should operate between 95 volt and 110 voltage AC, right? How would you test this machine device in terms of a voltage variance? So the first thing that comes into your mind is basically, okay, this machine, the medical device should operate between 95 and 110 volts, and probably you can actually say that we're going to test the less than 95 volts and between 95 and 95, and then 95 and 110, and then 110 and greater, right? So those are sort of common sort of a division that you can think of, and then normally you answer those questions. But here is kind of the trap, I think. We covered it in a previous video, but if you see the part one and part two, I think that kind of contribute to this particular question. Uh, if you just answer those per the equivalent partitioning area, that might not be a good answer, right? Because this one has some other aspect that the interviewer wants to know. When someone say you're testing a medical device, basically you need to understand the context, which is part two. What kind of medical device are we talking about, right? So is it a device that used in a surgery, or is that something like temperature checker? Is it the severity of this medical device? How serious when this device malfunctions, right? So you need to understand what medical device they're talking about. And again, you shouldn't assume um, that it is. You cannot assume that this one is any medical device in the hospital. You need to understand what this particular medical device is, right? And then it says 95 and 110 voltage. So you're probably thinking about this dividing these values. But the another thing that you need to think about is it's a medical device, and we need to ask. You need to ask what you know operates here. Operate. It should operate between 95 and 110. What does operate means? Like when it goes lower than 95, should we stop? Like if it is a medical device and then just does the operation on your brain, the patient's brain, it pokes the brain and it just machine dies and it just stop operating. What does that mean, right? So when you see the operation, when you see what device should operate between 95 and 110, again, this one need more context and we need to understand what that means. And then you can actually make, okay, I assume this way and I assume that way, right? So let's say, for example, so even we have a partitioning there, but there's some more cases around the vortice variance, right? So then what happened, since it's a medical device, there are various things we can do, right? So that, okay, yes, it does not work. It should not operate between less than 95. But when it goes back and come back, what would happen, right? So we need to think about the context of this operation, the machine that you're testing. Is it okay? Is a you know brief sort of go below 95 and come back is okay, or is it going brief like 110 to 112 just briefly again comes back, or when you're operating 100 volts and then suddenly dies, and what happened to the machines? There is it a circuit breaker? I don't know. There are particular things you need to ask a lot about this, and that has a lot to do with understanding the context. And if it is dangerous to the patient, you need to think about some other sort of requirements. Even if it's just ask about the voltage, the question basically asking you how much do you want to know about the context, and then how much do you care about the problem, the implication of malfunction, or what does should operate means, and things like that. So let me just kind of go down the thought process here. So basically, did you assume anything when you hear this kind of question? And then you have to think about, do I understand the entire context of the problem that I'm dealing with, right? So you need to keep asking the follow-up questions. Hey, what do you mean by operate, right? And then when you say medical device, you need to know what kind of medical device it is and the implication of when it doesn't operate. Does it have to gracefully stop the machine, or is it a backup, you know, battery or something that to support? So there are various things to think about, not only the equivalent equivalence partitioning, right? So that was kind of the trap that interviewer can put you on. So always think critically. Don't make an assumption. If you make an assumption, call that out, and then try your best to understand the context. And your testing strategy should be around that, based on the understanding of the context. And don't just focus on the equivalence partitioning and just give the range. That might not get you the good result for the interview. Okay. Okay, that's it for today. And if you like the video, please subscribe and then thumbs up button, please. Okay. Thank you. Have a nice day. Bye.